Hello everyone, so welcome back to Ronnie Explains. We are looking at multiplexers, and multiplexers are simply data selectors. It means if we have some data that is entering the multiplexer, like in this case we have the first signal is I0, then I1, then I2 and I3. Then all this data, if we want to select one of them to be displayed at the output, then we need some selector combinations. So we have to have these selector signals, and the combination of the selector signals will give us one of this data, and this data will be displayed out. So this is how it looks like. So the final circuit that we expect at the end of the video looks like this. So I will come to this spreadsheet document here, and if you look at this, I have my input signals here as I0, I1, I2 and I3. Then I have the selector pins as S1 and S0, and I have the output as Y. So I want to get the logic expression for this multiplexer. So this is what I'm going to do. If you look at S1, S0, those are 2 bits. So we'll have 0, 0, then we have 0, 1, then we'll have 1, 0, and then we'll have 1, 1. In the output, it depends with the combination of the selectors. For example, if there is a combination of 0, 0 at the selector, then I0 will be selected. So here we'll have I0. Then over here, selection of 0, 1 will have I1 being displayed at this end here. Then the combination of 1, 0 will select I2, and the combination of 1, 1 will select I3. So then we need to create the logic expression for this truth table here, and we are going to get it by Y because Y represents the output values. So what's going to happen here is that the first minterm will be created from this row. So we'll have S1 prime because the value at S1 at this point is 0. So we'll have S1 prime followed by S0 prime because the value of S0 here is also 0. Then the output will be I0. So here we'll have I0. Then we connect it to the next minterm using an OR gate, and the next minterm will have S1 prime because the value here is 0, and then the next one will be S0. Then the last one will be I1 because it selects the second signal, which is I1. Then we connect it to the next minterm using an OR gate, and the next minterm is gotten from this row here. So the first value is going to be S1, then followed by S0 prime, and finally we'll have I2. And then we connect it with an OR gate to the next, which is the last one, which is going to be S1, S0 and I3. So that's how we create the logic expression for this multiplexer. So the next thing that I need to do is to just design the circuit of this multiplexer. We will launch headers like this. Then over here I'll have some input switches. So I'll create these input switches here. I'll have 1, 2, 3 and 4. And their values are I0, I1, I2 and I3. Then down here I will have the selection lines S1 and S0. So over here I'll also need some inverters, because if you look at our table here, then you realize that some values of the selection lines have been inverted. So I will need some inverters. So I'll create gates, then I'll use the small inverters, and I'll have one here, and I'll have another one here. So the name of this is going to be S1, and the name of this one here is going to be S0. At some point I need to invert the signals, so that's why I connect them to these inverters like this. But after being inverted, the name of this one is going to be S1 prime, and the name of the second one is going to be S0 prime. Now I'll need to check my instant labels and port labels for me to see how the ports are labeled. Now over here, I'll have to check how many minterms I have so that I see how many gates are required here. So if you check at my minterms, I have 1, then 2, 3, and 4. So I have 4 minterms. It means I need 4 AND gates. So I'll come back to headers and create some AND gates here. And the AND gates are 3 input AND gates. So I'll have this as 1, 2, 3, and 4. The first minterm is S1 prime, S0 prime, and I0. So the name of this is gonna be S1 prime, S0 prime, and I0. The second one is gonna be S1 prime, S0, and I1. The third one is going to be S1, S0 prime, and I2. Then the last one here is going to be S1, S0, and I3. So now that we have these ones, we need to also combine them using an OR gate, and the OR gate is going to be on this other side. It's going to be a 4 input OR gate, so that's why I'll create gates, then OR gate. So I'll connect this to this OR gate here. I have to use a magnetic grid of 1/8. So I'll create this here. Then this will be connected to this, and this will be connected to this, and finally this here will be connected to this. Now I have to connect the logic. I0 is here, so I'll connect this here to this. That's I0. Then I1 will be connected here, I2 will be connected here, and finally I3 will be connected here. For the case of S1 and S0 and their negated values, I'll begin connection from S0 prime. The first S0 prime is here, so I'll connect this here. Then another S0 prime is up here, so I'll connect here and connect this. Then I proceed to S0. I can take it from here, so I can add a wire segment here and connect the first S0 is here. Then the next S0 is here. So I'll add a wire segment and then connect this one. Then I proceed to S1 prime. So the first S1 prime is going to be this one up here. And then the next S1 prime is the second one here. Then I proceed to S1. So the first S1 is this one, and the next S1 is this one here. So wire add segment, then I connect this. So the name of this output is Y. So this is how the circuit looks like. I can try to test this circuit if it works properly. So I will enable all the input switches. Then I will test one of them. Like for example, I can create a current that is flowing from I1. This is the zeroth, this is the first, this is the second, and this is the third. So if I want to select the first, I will have to have a combination of 0, 1. So if I have 0 and I have 1 here, then you can clearly see that it has been selected at the output. If I want to select this I3, for example, I know I3 is a combination of 1, 1, so it means this will be 1 and this will be 1, then it gets selected at the output. If I have these two like this and I want to select I2, I can see that, or I also have this one on and I want to select I2, I can see that I2 is off. So I2 is a combination of 1, 0, so it means this one is off, and now you see that no current is being taken at the output. Then I'll save this, so Control plus S to save. I'll save it in its own folder and name it as multiplexer. So mult is just okay. So then this one I'll name it as circuit. Then now I need to create its symbol. So I'll come to edit and create symbol. Then I need to create its sub-design. So I'll come here and open a new file. Right click and create its sub-design. So this is the sub-design of the circuit. The name is multiplexer or max. So I'll have the selection lines. For S1 and S0, I'll need a combination of two hexadecimal switches. So I'll create IO, then hexadecimal switch. So I'll need two of them. The first one is going to be here, and then another one will be here. Then over here, I'll have the input switches. So I'll create IO, I-pin switch. So I'll have 4 of them. So that's why I'll have 1, 2, then 3, and 4. The name of this is I0. The second one is I1. The third one is I2. And the last one is I3. So this will be connected here. Then this one here will be connected here. Then this will be connected. This will be connected here. And the last one will be connected here. I need to connect the switches. So the first one, which is S1, will be connected here, and the last one will be connected as S0. On this side, I'll create an output which is just an LED, and then I connect this like this. So the name of this is going to be Y. Then I can activate my input switches and the selection. So if I want to test it, for example, if I want to select I2, which is having current passing through it, then I2 is 1, 0 in binary, so I'll come here and select 1, and then this one is 0. So then it is being shown at the output. If I want to select, for example, I1, which is off, then I will come here and select 0, 1. So this will be 0 and this will be 1. And now you can see that clearly that it's having 0 current because I1 does not have any current flowing through it. So guys, that's it for this video. If you enjoyed watching this video, please give it a thumbs up. Consider subscribing and also sharing the video with your friends.